Welcome to Study Loop.
This is the answer to Chapter 13, problem number 44 from the Smith Organic Chemistry textbook. And so this problem is giving us three sets of mass specs and IRs and asking us to draw a suitable molecule for each set of data. And so for A, we're given a molecular ion of 72 and an IR peak at 1725 wave numbers. And so basically we know that IR peak should correspond to a ketone. And so I wrote that down in green. So that's the first piece of pertinent information. And then we'll look at the mass spec. So since we know that there's a ketone, we know that there's an oxygen. So oxygen accounts for 16 atomic mass units. 72 minus 16 gets us 56. And then I think the strategy for this is to start by assuming that you have as many carbons as you can to get to that number without going over. So carbon accounts for 12 atomic mass units. So 4 carbons would be 48. And then fill in the remaining mass that you have with hydrogens. So 8 more hydrogens, 48 plus 8 gets us to 56. And then we have the one oxygen that we said was present. And so given this formula and the fact that there has to be a ketone in it, this is really the only structure that we can draw. And so for B, we're going to follow the same process. So our molecular ion is at 55 for B. And this stands out right away because it's an odd number. So we can assume that there are an odd number of nitrogens. So since it only weighs 55, probably 1 or maybe 3 nitrogens. But certainly not, 5 nitrogens because, again, the molecule only weighs 55. So then by IR, we have a peak at 2250 wave number. And so that is going to correspond to a carbon triple bonded to a nitrogen. So further confirmation that we have a nitrogen in this molecule. Then as we did for A, we'll take the whole mass and subtract the weight of 1 nitrogen. This leaves us with 41. So we can have 3 carbons, which will account for 36, and then fill in the gap with 5 hydrogens, and that gives us a formula of C3H5N. And again, we know that one of the carbons is triple bound to the nitrogen here, and then we just fill in the other 2 carbons and their attendant hydrogens. And then for C, we follow the exact same formula that we followed for A and B. So our molecular ion is 74. Our IR peak pretty clearly represents an alcohol. So we can subtract 16 from 74, which leaves us 58. And then following, again, the formula that we've been using of, as many carbons as possible, that would be 4 carbons for a total formula of C4H10O. And so really, you could draw this molecule a lot of different ways. There are, the alcohol could be at various positions. The carbons could be moved around a little bit. But this is just the most simple answer that I've drawn here. But there are several other answers that would be acceptable for C. And that is the answer to Chapter 13, problem number 4.